Hey everybody, let's move on to the next unit, interactivity. This is a fun unit where we learn how to react appropriately to user input. We've been doing this throughout the term in some of our examples and assignments, but now we're going to learn about it a little more formally, okay? So, how do we make programs is the big question. How do we make programs respond to user input? So there's a couple of ways that this can work. So two basic approaches, okay? And no matter what you find, it'll typically fall into either one of these two categories. The first category is called polling. Polling literally means to ask, right? You're asking, you're inquiring. So polling is where you ask, what's your state, okay? And you do this periodically, as you need. Periodically read the device state. You read some variable, you read some memory address, you do something. Okay, and polling often looks like this. You have your program loop. So your program's doing something in a loop, right? Drawing and doing all the work that it has to do. You have a lot of code going on. And somewhere in there, you're going to call some code like get mouse position. And it's going to read the driver or read the device somehow and get that position for you. And then you can use that information to do what you want to do. So for example, if the position changed, this is like a mouse, the mouse moved. Then you do something. Okay. So polling is kind of a classic way to do these things. It's very simple. It's what you'll see in simple machines, embedded systems, that kind of thing. You just call a function, right? It's simple to use. Or you read some memory location, something like that. However, it's not perfect. It has a lot of problems. So even though it's simple to use, you just, what's the mouse state? You read a variable. It does end up cluttering your code. And the reason for this is because you need to manage this in your main loop somehow with a function call or some code. Now you might think, what's the big deal? I'm just checking a mouse position. But now I'm checking the mouse position and seeing if it moved. I'm checking the button to see if it's been clicked. Maybe I'm checking for a double click, so I'm keeping a time of when the last click occurred. And by the time you add in all these cases, you end up with a big chunk of code. It also wastes cycles. It's wastes computation time. Because even if nothing changed, you're going to check and calculate. So with polling, you check. I always like to think of it as, kids in a car. Are we there yet? Are we there yet? Are we there yet? No, we're not there yet, right? So polling is kind of like that. Are we there yet approach. There's also the problem what if you missed it? So let's say you're trying to check if the mouse button has been pushed. What if it's pushed, the state is down, you're doing something else, and by the time you pull, it's not pushed anymore, and you missed that push. So with polling, you can miss events. Okay. So the state can change before you check. Now, of course, if you're relying on polling in the real world, even simple machines, they can have device buffers. right? So even if you're you miss it, it should record like, did a click, the last 3 operations, or did a click happen that you didn't get yet, and then you clear it once you've gotten it. So there are ways to bypass this, but it does require work. Let's give a demo. Demo number 0. All right. Let's see. Here we go. Desktop slides. So here's desktop slides. So we have this program at 640 by 640. No big deal. By no big deal, I mean these things should look familiar. I call some code called random box, and I just set a box to be at a random location. No big deal. And then in my draw loop, I do all my usual drawing stuff. I call draw shape, which draws my box. And then I do a polling solution. This is polling because every time I draw, now remember we're drawing 60 times a second, right? And each time I go, is the mouse pressed? I'm reading some variable. It checks the memory, right? Now behind the scenes, in order for this to work, before my draw function calls, something checks the mouse and updates my variables for me. This could very well be a function call in many languages where you do it yourself. But the same thing is there. It requires this constant update. So I'm polling, I'm checking every single time I draw. Is the mouse pressed? Is the mouse pressed? Is the mouse pressed? If it is pressed, I'm going to print mouse pressed here, and I'll do a check. We'll come back to this check in a second, but what I want to highlight is this is my main loop, right? Either I put it in here, or maybe I call it a function to simplify it. Check mouse pressed. I'm cluttering up my draw loop. It's more work I have to manage and do right in the draw. So I run this. I have this program. Cool. Okay, now what's happening is it's checking if I push the mouse every time it draws. So down here you can see if the mouse is pushed, it says mouse pressed. And then what it's actually doing is it's actually checking here if the mouse X is to the right of the left border, and the mouse X is to the left of the right border, and the Y is below the top, and the Y is left of the right, bottom rather. So it's basically checking if we're in bounds. If my mouse X and Y coordinates are within the bounds of the box, it's going to print line hit. Otherwise, it's going to print line missed. So you see I'm missing the box. The other thing that's going to happen is if my mouse is inside the box, it's going to move it to a random location. So cool, we can do hit testing. But this is a polling solution. There are 2 spots where there's polling here. One is the mouse pressed, and one is getting the mouse location. Okay, we're polling these, and we're checking it 60 times a second. It's simple. We use this in 1010. If you want to do something quick, it's fine. It just doesn't scale very well. Okay, so that's polling. If we don't do polling, then what do? The second approach is a little different. It's based on the use of interrupts. Now, you should have learned about interrupts in your comp org class or one of those classes. You might, if you haven't done operating systems, you might not have a lot of practice with this yet. But I'll just quickly go over how this works. You set up a routine, like a function, right? And you register it. As an interrupt handler. So what you do is you tell the computer, hey, when this interrupt happens, call my code. So it might look something like this. Mouse.register interrupt handler. Probably looks better if I do it this way. Mouse.register interrupt handler, and I give it some code function name. Mouse handler. And then I set up my interrupt handler, and then I go on. This is my rest of my program. I forget about it. Okay, so I set up an interrupt handler. I tell the mouse, hey, look, mouse handler is a function, and when something happens in the mouse, call that function to handle it. Then somewhere else in my code, I have to define that function. Right, so here's my function, mouse handler, and inside mouse handler, this only gets called, for example, when the mouse changes. And then if the mouse changes, it calls the interrupt handler, and then I react to the mouse. Okay. So in comparison to the polling, you separate code from the main loop. You put it on the side and it only gets called when the interrupt happens. So it's cleaner. The other thing about this approach that's quite nice is that you no longer busy polling. No polling, no busy looping, no checking. So no wasted checks. You're not doing are we there yet. So under the hood, what happens is you set up your code and your program does whatever it wants to do, something unrelated. And then when the interrupt happens, the interrupt fires, it suspends the program, then it runs your code. Okay? So you're not busy waiting, it's cleaner, and a lot of the problems of polling, they go away. Now, of course, interrupts aren't a perfect solution. There are problems here. If you've done interrupt programming, or you've done them in operating systems, interrupts are messy. Are really messy. They're hard to program. They're hard to do well. And the reason for this is that your program can be interrupted at any time. And if you're modifying global or shared memory, there's a mess that can be had. Okay, so it's challenging. There's a lot of caveats. You need to be an expert in that work to really program interrupts properly. So what happens is these are usually handled for you. Okay, this low-level stuff is already taken care of by the operating system, for example, or a library that you're using. It's basically solved for you. And what they do is, if your operating system is handling the interrupts for you, how do you interface this? Or if a library is handling it, how do you interface with this? Well, they provide a higher level system for you to work with. An abstraction. A higher level abstraction. And then you use this in your program. Provides a higher level abstraction to use in your program. And these are basically event systems. So interrupts is a great idea, but it's low level, it's quirky, and you need to understand operating systems and concurrency and a lot of concepts to get it working properly. So they can be really challenging. So the solution is someone solved it for you, and they provide you with an abstraction under this title of event systems. Okay, so it's a good place to stop. I'll come back and we'll learn a bit more about how event systems work.